Hello.
Hey, all right. I think we're live here. Hey everyone, welcome to the second Rise sessions. No script, no polish, just us having a chat about what we're building, what's working, what's not, and a chance for us to get closer to the community. So this week, I'm excited to bring Hai. Hai is my esteemed co-founder and CTO. And probably the biggest pain in my ass day to day. In our team, that is actually a good thing. But yeah, Hai and I have been along for the journey since day one. But before we kick things off, Hai, do you want to give a quick intro to the community?
Yes, hello everyone. So my name is Hai. So the T in my title actually stands for trolling because that's apparently what I do at the company mostly. But yes, I also do some technical works on the side. But yeah, so been cooking for over 2 years now, and yeah, very excited to share and talk more with you guys about what we're doing. Still so much close to starting line. Can still do much more. So yeah, pretty excited.
Awesome. All right, let's jump straight into it. So I've ranted on about our founding journey many times, but I'm kind of keen for you to have a chance to share the story from your perspective. So how do we start this out? Why did we decide to build the fastest L2? And you personally decide to burn precious opportunity cost on this. And how has this thesis played out?
Yep. So there's many parameters to this forum, but I guess like personally at this stage, I'm just really excited about building cool technology. So I have many crazy ideas, but sometimes just I need to do something cool. And so when the Rise opportunity came up back in late 2023. And just something I feel like I can do well, but also something like maybe can be meaningful to users. So at that time, we're just playing around, and time flies by. And before I know it, I was deeply in love with what we do. And so yeah, so just spend a lot, every day with the guys doing technical works, making things fast, but also like very principle engineering. And I think the best thing I love about Rise is actually is this is like a very weird thing to say, but it's actually the culture and not the product yet. I mean, like we can do a lot more for the product, but Rise, is interestingly a environment where I can be principled and be creative. There's no bullshit like you have to make up good numbers to sell that. There's no like we need to chase it narrative and that. I mean, there's some of it, but not to the extreme. But being aligned with something. So all the numbers I report, all the numbers we do are very honest, and to be in such an environment like do honest engineering. That's awesome.
Awesome, man. And tell me about your take on the performance landscape today, maybe specifically the EVM performance landscape.
Okay, so performance is very interesting because there's a lot, when it comes to performance, the throughput and latency. But I guess like sometimes even like UX and users happiness can be one kind of performance, right? So it's very broad. But I guess like for EVM alone, I think the most interesting thing is that 2 years ago when we started this journey, we spent a lot of time working on parallel EVM and database design because the EVM itself was very slow, and the database, the localization of the MPT tree was very slow, and everyone was just like gaslighting each other that we need a better tree, we need a better virtual machine, and a lot of projects pursue that, and obviously we did as well. But through some pretty disciplined engineering, we could make the EVM and the MPT SE go pretty fast, and so that is pretty eye-opening. So sometimes you just have to do like principle works and just not chasing narratives and that stuff. Although obviously we're still going to pursue our EVM and our database and tree, but yeah, we can get a lot more out of the current technology, and we don't have to sacrifice compatibility. We're already a very vibrant EVM ecosystem, so that's a very good position to be in at the moment because like all other EVM chains are struggling to scale a bit, but we with EVM alone is still scaling very well. So I think that's the very good for us.
Yeah, if we go back to 2024, there was actually a lot of pressure for us to optimize on the VM, and we were pretty stubborn about it. That we saw how valuable it is to have a language that everyone is familiar with, that it's widely supported by the tooling. Even today, we're seeing the benefit that, say, a native stablecoin issuer, they can issue on an EVM chain a lot faster than they could have a custom chain. And still today, we see most of the activity being on 2 different VM types. So in hindsight, it was the right call to really like double down and optimize for the EVM. It was a risk because we didn't know if we were going to be able to make it fast enough, and fortunately, we have been. So let's jump into the architecture a bit. So on a typical day, as of the past few weeks, Rise makes up or consumes more gas than all other L2s combined, all other L2s plus Ethereum combined. So we're typically 50+% of the total EVM gas usage in that cohort. So we've clearly optimized quite a bit. So tell me about the Rise architecture. Like, what's different about our stack? How are we able to hit that performance?
Yes, and I would like to clarify just a little bit, because before people take things out of context, like when we say that the EVM is fast enough and the Merkle tree, MPT tree is fast enough, we mean like in our stack. So like, we did a lot of optimizations and low-level optimization and node-level optimizations around that to make it fast enough. So I think the biggest thing that we've done so far is the block pipeline, so continuous execution. So like right at like in the early, like the first month of 2024 or something, when we got deep into benchmarking, finding the bottlenecks in EVM, and we obviously found that actually for a block time in the OP stack or in the Ethereum, for example, you spend a lot of time on random things like consensus and just serialization of data and all that stuff. And you only spend like 12% of the block time to actually execute user transactions. And it was a big surprise for me. And obviously, the first thing we tried is to pipeline transaction execution so that we can get the receipt, the execution result back to the users as fast as possible, and spinning 100% of a core instead of just being idle most of the time doing just irrelevant things to the users. And so when we done that, we did a lot of optimization around that to make it work as well, because obviously it was not that easy, because to execute the next block you need the block hash of the current block for some opcodes, so it's not completely easy. So we spent a few months refining that, optimizing the hell out of that. And yeah, so the result is that we end up with a system where our receive transaction inclusion latency and receive latency is just the best among all EVM. And obviously throughput wise, if you look at what the fuck today, then we also like super solid. So I think the last benchmark we did a few months ago, we were like 3 to 8 times higher throughput than base and OP optimism, and we have like 50 times lower latency for our shreds when compared to flash blocks. So pretty good, I would say.
Let's double click on shred. So one thing we do definitely is we execute transactions continuously rather than in discrete blocks. Can you just share more about that kind of shift in our approach?
Yeah, I guess like at the end of the day, we were just really wanted to get the transaction result back to users as fast as possible. So we are at somewhat still a very practical company, right? We really care about users and what they think, and also like as the Web3 users ourselves, like obviously today sometimes we do some multi-sig and some transaction on L1 Ethereum, and it takes like 7 minutes to go through, 12 minutes to go through. And that's definitely, even for technical people, even for Web3 native people, that's just unusable basically. And so, this notion of, trying to get the results back to users as fast as possible is just very intuitive for us. But also like for many applications where, we see with trading, like latencies matters a lot, like every millisecond counts. And obviously like in traditional high frequency trading, we are talking about nanoseconds. So we're not there yet because we add a lot to that with blockchain technology, we have the transparency, we have the immutability and all that stuff. So we're not competing with that yet. But like among Web3 and blockchain, we are very, very fast.
What do you think what's the end game? How fast can we get?
Well, I think that we have enough ideas to do like sub micro a millisecond inclusion, at least like for small transaction like canceling orders in RiseX and all that stuff. But that is just like without any big architectural changes. Like if we do, custom hardware and all that stuff, I do think we can flirt with nanoseconds. But obviously, like there's a trade-off, right? Like in high frequency trading in like in a stocks market or whatever, exchanges, traditional exchanges, you don't have the transparency, you don't have the immutability, and for example, if we look at FTX, right, no one knew like when they went insolvent, but for fully on chain, everyone can watch what is happening, and everyone can run their own node to validate every single block that they are honest. And so obviously that's a trade-off. But I also think like even in the range of milliseconds, that would also already enable a lot of applications. And so I think it's a good balance to have.
Absolutely. Now, another area we were able to find a lot of optimizations was vertical integration. So by integrating directly with RiseX, we've been able to make things a lot smoother for the user and improve on performance quite a bit. But can you talk to me about that in specifics? Maybe if you've got an example of where vertical integration was actually really valuable.
Yeah, sure. So by vertical integration, we are really talking about the benefit of building both the chain and the exchange, right? Both the chain and the app. And so there are many examples, but for example, like in a traditional Web3 setup, right, an app would talk with chain through RPC, and RPC is actually very painful. It's very slow. It's very consistent. It's very hard to scale. And so all of the apps indexing the data through RPC would really lag behind, and also like the validation is very painful because that when you subscribe to an event to all the logs of your application, for example, like everything that happens to your application, what happens if there's a lost message, right? You have to revalidate and re-backfill all that stuff, and so that latency to that is like a slippery slope to that. So when we do vertical integration, we can embed like RiseX indexing logic right into a Rise node. So for every single block, income block, we do the validation and indexing in parallel. And when the validation completes, like, okay, the stable adds up, the block hash adds up, this is a valid block, we commit the whole all the index data to the database. And that is like perfect indexing. There's no missed messages, like there's no latency because you have to go through a hop of a network RPC. Instead, you're just indexing right inside your node's memory. So that's for indexing, and that's for reading, but for writing as well, right? So for example, like we do co-locate a RiseX transaction builder with the RiseX chain sequencer itself. So we just need to send some intent to build some transactions, and it's going to be building it locally, and it's going to talk to with the sequencer to IPC without any network at all. So the latency minimal, and it's pretty much impossible to have non-inconsistency because of how reliable this same machine connection is, and so we keep the data that flows through a network bare minimal to the intent and to the intent result instead of a fully built transaction. So all of these do add up, and it's funny because like it can be and I think my favorite example is when the exchange engineer comes up with an idea like if this could happen, if we have this new RPC today, it would help the exchange index data like 3 times faster. And so in another chain like in Ethereum or in like another rollup, you have to go through this process of writing an improvement proposal. You have to go to talk with the community and sell them this idea. You have to, and even when the idea is well taken, you have to gaslight every single client to be like, can you prioritize this, please? And you have to wait for a few weeks for it to be implemented, a few more weeks to be released in a major release, and then you have the RPC. But for us, it's like, you know what? I just ping some dude from the chain team in Slack and gaslight them to implement that. in a few days, and the next gen upgrade will have that already. So this feedback loop is like 0 times faster than in a traditional setup of having a separate team building the chain and having a separate team building the application. So it's helped with your runtime latency, it helps with planning, it's helped with the feedback loop, it helps with everything. So I'm very confident that this setup would help us build like a extremely good exchange outright that get the best out of both worlds, so performance, composability, but I guess like also like transparency and immutability of the blockchain. So it's
I
pretty
think,
awesome.
I think if you look at that, how that compounds, like if every time you have to make a change, it's going to take 2 days versus 10 weeks, like that's you'll accelerate a lot faster if you're able to get that feedback loop in. Awesome, man. Now, I wanted to jump into your engineering philosophy. You're very well known in the team for being very specific about how you operate and the standards that you have. We call them high standards for a reason. So yeah, I just wanted you to take an opportunity to tell us about your engineering philosophy and how you apply that to building an engineering team.
Okay, cool. So this is very unique because like I genuinely love engineering. So it's not like I'm here because I want to make quick buck. Like I just genuinely love like the technical details and all these tiny details around how to make things work, like and how can make it fast. And so I really spend a lot of effort and to try to bring that and to build that into people as well. And it can be a cultural shock to some engineers, but they eventually love it, hopefully. But yeah, so the standard is just like, first of all, my favorite number one, if I only need to pick one principle, it has to be like fundamental. Like I feel like a lot of engineering nowadays, especially with AI, it's just like looking at like if something broken, you try to fix it and you test it, and if it works, then it works. Or if you look at the code and you find that, okay, so the current code is doing something like this, and if I mimic that pattern, maybe it will fix something. So basically by assumptions, by patterns, and all that stuff. But for me, fundamental is just basically you have to understand why something works, and it's not just like you see it working on the screen, so it probably works. But it's still truly understanding, like, okay, so for example, like in system engineering, for example, like you have to know like who owns this data, right? And the synchronization, like the access pattern of this data, or like just at the protocol level, like what is this and what it affects, consensus. Like if this, misses a byte, and does that affect like reorgs? Does that lead to reorg? Does that lead to nodes refusing to follow each other? And you basically have to understand all that before making a technical decision. So it could take a lot of time to get things through, but I think at the end of the day, it really compounds. But if we want to go a long, game, then understanding how it works is just so obviously important. Otherwise, so yeah.
Awesome, man. Now you use a term in the team. You use it, Stallions. It's how you refer to the engineers in the team. You put a lot of effort into building a really strong engineering team, and I know you believe that quality over quantity is really, really valuable. So tell me, like, what are the common traits of the best talent you've been able to, or what you've seen from the best talent?
Well, this is pretty tricky, but yeah. So I've basically been interviewing like 300 engineers for Rise throughout 2+ years, and our offer rate is under 10%, I believe. No, way lower than 10%. So, and I mean, like to pass screening, you basically need to be a senior in the first place. And so I guess like to me, oh, it's pretty funny. So nowadays, actually, the standard is pretty low, especially with AI and how good they are. Because like AI is so good, so many people
the standard that you see coming through the pipeline.
I mean, like just saying generally about engineering at the moment. So like because AI is getting very, very good, so a lot of people just delegate a lot to AI, and so sadly, to be a good engineer nowadays, you just need to be like still have some critical thinking lab inside you, some awareness and some domain knowledge. Like other because like during interviewing, I see a lot of very sad patterns of So the question is pretty simple, like some coding changes that just need a few lines of code, but the candidate would just like ask Claude and just sit there passively for 7 minutes, and I definitely don't want that at all. So I guess and also AI has very broad, and they have a very wide range of knowledge. Like it knows a lot about Rust than me, for example. Like these tiny, language features. So that is not something I'm looking for really. But I want domain specific. For example, a very nerdy low level performance tuning. That is where AI is lacking. We cannot ask Claude for that, and so we need engineers who can do that low level thing, and also critical thinking in general. Like it's so tempting. Like you're 6 hours into your workday, you're tired, and you have this small task to just throw to Claude. But I want the engineer to be like, okay, if it's something I can still do, then I would try to use my brain as a practice at least to get through it, because it does compound. I feel like if you can exercise all this stuff into daily, then when it comes to like take very hard technical problems where AI cannot solve, then you can actually have some energy and some reflect to actually embrace the challenge. So I guess so it's funny because so basically I feel like most of that is actually mentality on the mental side of thing and not the technical side of thing. Yeah.
It's interesting that it's like consciously taking the higher friction route, because long term, it's even long term and short term, it's the better approach. But it's so elusive just to run a Claude script and sit there for 5 minutes and let your brain kind of drift off. But that actually, there's a lot of parallels with that and security. That I think good security, you brought this to my attention, was essentially just taking the high friction route at every opportunity. So security is front of mind right now in the industry. We've had some of the biggest hacks. Can you share some insights into how we tackle security at Rise?
Okay, so security is a very complicated thing, right? And there, like on the technical side of things, there are many techniques that we can do. We can have like cold wallets, hardware keys. We have dedicated signing things, machines, and then you have all these setups, best practice, and then security is just all over the places, right? In system code for the blockchain, you can have memory access errors. In the backend code, you may have like authentication issues, DevOps, stolen keys, and even on front end, right, you have like compromised dependencies. We have seen with React and Axios and all that stuff. So on the technical side, I think it's very broad and flexible. So I would not be able to cover it in a few minutes. So I would focus more on the mentality side of things, mental things side of things. So I think the most important thing that I'm trying to sell within the company is that everyone has to do security, right? I see like a lot of companies and a lot of places, people just think that, okay, security is something very scary and very technical, and it has to be for the professionals. I cannot do that. We have SecOps, so DevOps don't have to care about security. We have security researcher, we have like smart contract auditors, so smart contract engineers don't have to care about security and all that stuff. But I think we just have to embrace security. Like obviously we're not professionals, so we cannot like do it all the way there. But to have to be fully aware of like, okay, I can make this design a bit more robust and secure and just do it. I would be more careful with my dependency management. I do it. And when someone asks me to do something, you just ask the question, do I actually need to do that? Is this person genuine or trying to do something? So just small things that I do compound. But also like on the other end, on this other end, like I see, like recently we have a bridge hack, which is very funny. Like that team is like very confident, like arrogant even. So you see that the trolling white hats.
This isn't the layer 0 hack. This was the one previous to that.
Hyperbridge, I believe.
Yeah.
And they just be like, White House coming, knocking, and saying, "Okay, I found some issues. Can you have a look?" No, if that's a real issue, just hack us. And and that is also something we don't do. So we do embrace security. Everyone has to do security, but we do have to remind ourselves that we are not professional, right? We do not be cocky. And so we still hire auditors. We still do consultants with the best security experts. And so, I think we so far spent over 200K on audits. So, we're still doing it properly. We're not going to take shortcuts and, so not abandoning things, but also not taking shortcuts, taking it very seriously.
I think it might actually be double that, including the chain audit.
Could be.
It's up there, yeah.
Yep.
Awesome. All right, let's move on to the technical roadmap. Can you talk to me about what's next for the chain, and even if you want to touch on RiseX, what's the most exciting stuff that we have on the roadmap?
Oh, there are just so many things. I guess like on the chain side thing, the mempool, we've been really excited to ship that. So the mempool is a very important piece, right? It's basically the controller of your transaction latency. All transactions have to go through the mempool. So if the mempool sucks, then just latency is very bad even before execution. And but also like in the VM specifically, like there's just so many knowledge issues. So we have been redesigning our mempool. So we rewrote and rewrote it and redesigned, rewrote a brand new mempool that has nothing to do with the standard mempool that REST ships. And so it's had like sharding, so very good latency, very good concurrency. And I would say we should not have zero knowledge issues from there. But also like not just about transaction latency, but the mempool is also something that is very critical to vertical integration, right? So for example, like for RiseX, obviously cancel orders is very important for market makers. Right? They do very aggressive, of orders, and when price changes, they want to cancel the outdated ones so that they don't get drained too easily. So to be able to prioritize cancel orders right from the mempool level, just improve quality of the exchange so much and simplify a lot of things that we do not need to hack at the block building level. So the mempool, and also like so apart from outside the mempool, also be rewriting the chain engine, getting away from the chain engine that REST ships, but also like parallel VM is a big one. So we already seen that during aggressive market movements, we are burning a lot of gas, 1.5 gigagas per second even. So we need a lot more gas, and so I think our roadmap. Our midterm roadmap has like 7.5 gigagas, and our long term is 12 gigagas per second. And so we need parallel VM to get there. And also, not parallel VM is not just like something that help with throughput, but also with latency, right? Obviously. So instead of having with sequential execution, the transaction, like even if you have a very, very fast executor where there's traffic and congestion, if you are the last transaction in a block, so technically your P95 or P99, you still have to wait for every single transaction before so your P95 is still like 900 plus millisecond, and that is just impossibly slow for an exchange. So parallel VM solves that by, so imagine you have different transactions executing inside, among different markets. They can all be done, processed in parallel. And so, the latency is not necessarily the sum of the latency of all the transactions before you, but even you at the last transaction of the block, you can still have the same latency with, a transaction like 200, position above you, ahead of you. So that is a big one, but probably takes some time. But yes, just so many we were doing.
Actually, I want to ask about parallel EVM. So one of the biggest pushbacks on parallel EVM is that there's often hot state where it's the most desirable state in the block. Everyone wants to get access to that state. And if everyone wants to get access to that state, it's not parallelizable. So how does that play out for an order book, for instance?
Yeah, I guess like, so I mentioned that, orders in in different markets can be parallelized, but also like there are many user actions that have nothing to do with orders, right? You want to delegate to a new signers, you want to update your leverage in the market, and basically you're touching different parts of the order book, so they are very parallel by definition. But also like one thing that we have been doing with parallel EVM is that we can do a lot of things in parallel, even though in theory they're sequential. So when we solve the beneficiary accounting problem, so basically So by in theory, like all transaction in the block pays to the same beneficiary account, which is the mind of the block if you think about it. So by definition, all EVM transactions are sequential, but we can still make them parallel with lazy updates and all that stuff. So just imagine that when you process the transaction in right? So even when there's a congested state, right? You just imagine that we only need that specific things to be sequential. Everything else can still be in parallel, right? So if you load state into the memory, for example, you read state from disk to memory, that has nothing to do with the congested state. That can still be done in parallel. And if you do some VM, tags, like you have to set up some things, you have to set up some memory space, you have to do some accounting on the gas payment, then has nothing to do with the congested state in the order book. So I think the vertical integration comes back here, where if we build parallel EVM that is rising aware, then even when in theory some states are congested and shared, we can still work around that. Like we only have like congestion at that specific moment. Everything else can still be done in parallel. So I think if someone would say that parallel EVM would not work or would not work well, probably just skill issue. So
All right, nice one. Good stuff. I'd like to wrap things up with a few questions. So we've got a few here. So LSD Jun's got one for us. How to prevent risk across protocols during extreme volatility without isolating liquidity, since everything is a shared state. So I think that is essentially how do we handle the extreme volatility across many markets and a lot of state.
okay, so I guess like this is probably related to the recent incident with layer zero, right? So first of all, I have to admit that we also use layer zero, right? But we again like we are somewhat security aware enough that we do 2 out of 3 instead of 1 out of 1. So obviously like that's the default when you follow a README of layer zero, but obviously thankfully our engineers are security aware enough to do both that. But also like we do even for the source chain and destination implementation that we plug into layer zero, we have all these rate limiting, and we all have all these pausing and freezing and all that stuff. So and we also like even inside the order book, right? We have a lot of circuit breakers to prevent issues. For example, like for the Oracle, if the Oracle is stale, we would rather revert than to go for some transaction to go through. But also like we have some dynamic and open interest limit. So if we think even on chain that this is a lot more capital than we can handle, then we're going to prevent users from open such a risky position. So I would say that again, like this, it has the technicality of this is very complicated, but I think for us mentally, we do embrace this. Like we just have to always thinking about the worst case scenarios and adding all these layers of protection and defense. And the good thing about that is we can do a lot of these, and we are actively doing a lot of these on chain and automatic instead of having to have someone to click buttons. Even though we're pretty good at clicking buttons, we have PagerDuty for even like the smallest things ever. Like for example, like in our network, right, we have many nodes and we have block building sequencer and some replica node just serving some blocks, some RPC. So technically, even if an RPC node goes down, there's nothing happens to the network. But if a single RPC node lags behind just like 30 seconds from the rest of the network, we'll go to ring PagerDuty and someone's going to fix that. So that is just something we do. Very obsessed with correctness and stuff.
Yeah, very, very precise. Awesome. All right, next one is when public mainnet for the Rise ecosystem, or do we expect more invites for the public mainnet? So I can answer this one. Hi. So when public mainnet. We'll have some more details around this, but we will be rolling out the ecosystem soon. So hopefully within the coming weeks, the first apps will go live. Outside of RiseX, which is actually already live, so it's live in a closed beta. We've had a handful of users come on board and test things out, put some volume through, test some liquidations, that kind of thing. So many of you in the audience would have seen access cards going around on Twitter and on Discord. We will be winding things up in the coming weeks. So yeah, hunt down your access card so you can jump in and start testing it out. But as for the ecosystem, we're really eager to get it up and running ASAP. So we're working really closely with the ecosystem apps to get them live. But yeah, we've got a philosophy at Rise to roll things out steadily, essentially, scale responsibly. We don't want to just throw things out there before they're polished. So what you should expect when you do get to use RiseX is that it's polished, and when you get to use the apps on Rise, they're also polished. Awesome. All right, let's jump into the last question. Where is it? Okay, how does Rise optimize latency for high frequency trading or DeFi use cases? Actually, I'm gonna rephrase this a little bit. Does Rise optimize for high frequency trading or DeFi? Do you want to answer this one, Hai?
Yes, I think I kind of mentioned this a little bit before already, but yes, obviously, yes. So transaction inclusion latency is something we do very careful about, and we profile every single corner, we cut every last millisecond we can. So I would say yes. So for example, I mentioned we are rewriting our own mempool that is much faster and less frictional than Reth. We're shorting, not a single lock like Reth does. And then for the execution, obviously we use the continuous execution pipeline. So we spend 100% of block time executing user transactions and broadcasting receipts for users. And even in the networking layer where we're setting up at the infrastructure level, we do everything we can to reduce the hops and to kill all the latency down. And so again, like we are not going to approach centralized, completely centralized and private and invisible order books anytime soon, like with stock exchanges, But in the realm of Web3, we're just talking about hyper liquid or lighter, for example. We are extremely competitive. We're much better already.
Do you have numbers there? Like Hyperliquid's got a 70 millisecond block time. How do we compare for trades and cancels right now?
Yeah, so our shred is like 1 to 3 milliseconds. And we already observed some cancel orders transaction that got processed in under 1 millisecond, so microsecond round. So we're pretty good. Yeah.
Pretty good.
Pretty
good understatement.
No.
No, we don't celebrate too much at Rise until we dominate everyone.
We'll get much better. Like we have pending pull requests to cut a few more milliseconds already when there's a high traffic. So just
the transaction builder, co-locating with the sequencer, essentially sharing memory in the same CPU, is like that. That's going to be a massive unlock. I'm really excited to get that live.
Yeah.
Awesome, man. Hi. It's I see a lot of you every day, so it's a shame I had to see more of you, but we got through it. Appreciate you jumping on, and yeah, man, it was good to chat. Hope the community enjoyed getting to see a little bit closer into how the engineering team operates and how we think.
Awesome. It's been a pleasure. So yeah, love you guys.
Good stuff. All right, let's wrap it up there. Thanks, everyone.